In this lesson, we are going to go over square roots and simplifying square roots. So our objectives are to understand square roots, and then we will learn to simplify square roots. Okay, so first, square roots. As an example, we have the radical symbol, which is this symbol here. Square root of 25 is 5, and that's because 5 times 5 is equal to 25. Okay, so if a number is a perfect square, like 25, when you simplify it, there's no radical left because it's just a perfect whole number as 5. Okay, another way to say this is 5 is the square root of 25. So example, simplifying radicals. Use perfect square factors or prime factorization to simplify the radicals given below to give an exact answer. When it says to give an exact answer, it means that our answer is going to be written with radicals, which again is this symbol here. Okay, so I'm going to go over a couple different ways to do these problems. So I'm going to talk first about using perfect square factors, and then on the next slide we'll do this problem as well with prime factorization. Okay, so perfect square factors means that you write down all the numbers that can multiply to give 63, and you look at which set has a perfect square in it. And what I mean by perfect squares is 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, 25 is a perfect square. Okay, and the reason these are perfect squares is 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on and so forth. So we write our factors of 63. I always start with 1 times 63, and then I go up from there. So 3 goes into 63, 21 times, 4, 5, 6, and 7 times 9. So looking at these factors, 1 times 63, 3 times 21, 7 times 9. The factor 7 times 9 has a perfect square, with our perfect square being 9. Okay, so you can do this in a couple of different ways. The first is to rewrite this as the square root of 9 times 7, because 9 times 7 is 63. And then we can split this into 2, square root of 9 times square root of 7. The square root of 9 is 3, so square root of 9 is 3, no radical symbol. So this becomes 3 times square root of 7. Okay. Another way you can do this is you can write 63. Let's say you know it's 9 times 7. 9 is 3 times 3. Okay, so 3 times 3, one of them comes on the outside and the 7 stays under the radical. Okay, so whatever way you want to think about that is okay. Next, using prime factorization. So this is where we take 63 and we break it down into our prime factors. Prime numbers only are divisible by 1 and itself. So a number like 13 is a prime number. Okay, so 63, I'm going to start with, we can start with, let me erase it. I'll start with 3 times 21, and 21 breaks down into 3 and 7. Okay, so what this means is that 63 is equal to 3 times 3 times 7. Okay, so I'm going to rewrite this as the square root of 3 times 3 times 7. When you're looking for square roots, you're looking for pairs. So 3 times 3, 1 comes on the outside, and the square root of 7 would stay on the inside. Okay, you can also take it from your factor tree where we have 2 3s here, which means that we have a 3 on the outside times the square root of 7. Okay, so different ways to think about this and organize your work. Okay. Next, use perfect square factors or prime factorizations to simplify the radicals. So in this case, I will use perfect square factors, and then in the next example, I'll use prime factorization so that you can decide which way you'd rather go. Okay, so for this one, perfect square factors. So I start by writing my factors. 4 times 125, 5 times 100. I think that's it. Okay, so as I'm looking at this list, 100 is a perfect square because 10 times 10 is 100. So I'm going to rewrite this as the square root of 5 times the square root of 100. Square root of 5 can't simplify anymore. There's no more perfect squares there. So this is square root of 5 times. Now the square root of 100 is 10. But I always recommend when you've got a whole number like this that is supposed to be outside of the radical, write it in front so that it's clear it's on the outside being multiplied. Okay, again, another way that you can think about this is 500. Let's say you know 100 times 5. This is 10 times 10. Okay, here's my pair. So we have 10, and then the 5 stays under because it doesn't have a pair. It's all by itself on the inside. Okay, actually, I'll do this one using prime factorization as well, because the last one is a little bit different. Okay, so prime factorization, so we start our factor tree. So I'm going to start with 250. 250 is divisible by 2 because it ends in a 0. 125 is divisible by 5 because it ends in a 5. Okay, so I'm going to write this as square root of 2 times 2 times 5 times 5 times 5. And again, we're looking for pairs. So we have our 2's and our 5. So that means a 2 is going to come on the outside, a 5 is going to come on the outside, and this 5 stays on the inside. Okay, so we have 2 times 5, square root of 5, which is 10 square root of 5. Okay, you can also take it from this factor tree to where you would take 2 times 5 on the outside, and then the 5 that's left goes in the radical. Okay, so the answer here is 10 square root of 5. Next, use perfect square factors or prime factorization to simplify and give an exact answer. So we have square root of 100. So what I want to do here is just emphasize that when we have 10 times 10, that is the square root. Okay, so this is not square root of 10. The answer is just 10, again, because 10 times 10 is equal to 100. Thank you for watching. If you have any questions, please feel free to reach out to me.